Hello everyone, welcome to this challenge question walkthrough for Edexcel's Pure Year 2 textbook Chapter 2. Okay, our first question comes from exercise 2a. We're given two functions f of x equals the modulus of x squared plus 9x plus 8, and also g of x which equals 1 minus x. And part A wants us to sketch these two on the same axes. So, if we think about f of x first, to draw modulus graphs, you should always draw what the graph looks like if there was no modulus sign. So first doing that, if we factorize this quadratic, we get x plus 8, x plus 1. So we have two solutions at x equals minus 8 and x equals minus 1. So if we draw the graph of this parabola, we know it's positive, so it will look something like this. And we also So if we look at f of x first, if we think about drawing the sign with no modulus signs first, so if we're looking at f of x first, then to draw a modulus graph, the first step is to draw the graph without modulus signs. And we can factorize this quadratic here to give us our roots, which are going to be minus 8 and minus 1. And the graph will look something like this because we know it's a positive quadratic. And these points here are going to be minus 8 and minus 1. Okay. Now to turn this into a modulus graph, all we do is reflect everything underneath the x-axis above it. So that'll look something like this. Here we're fine, and then here we're going to reflect, and then here we're fine. Okay, so that is our modulus graph. Now for g of x, we can have a graph that looks something like this. Okay, where the intersection points with the axes are both 1. So this is our y equals g of x, and this is our y equals f of x. Okay, now for part B, we're asked to find the solutions to the equation f of x equals g of x. And to do this, we're going to look at all of the intersection points. So here, 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 and here. And to start with, if we think about the intersection points where the graph of f of x was initially positive, so that is this one here and this one here, where we didn't have to reflect the graph upwards, then these solutions are going to be given by positive x squared plus 9x plus 8 is equal to 1 minus x. And if we rearrange and solve, so adding x to both sides and taking 1 away, then if we use the quadratic formula or your calculator, we're going to get the solutions minus 5 plus or minus 3 root 2. Then for the parts where the graph was initially negative, so that is here and here, then we're going to have minus x squared plus 9x plus 8 equaling 1 minus x. So we have minus x squared minus 9x minus 8 is equal to 1 minus x. And if we take everything over to the right hand side, we're going to have x squared plus 8x plus 9. And again, using the quadratic formula or your calculator, then we get the solutions minus 4 plus or minus root 7. Okay. So our four solutions are x equals minus 5 plus or minus 3 root 2 and x equals minus 4 plus or minus root 7. Okay, our second question is from exercise 2g, question 1. The functions f and g are defined by f of x equals 2 times the modulus of x minus 4 minus 8 and g of x is equal to x minus 9, both for x and the real numbers. The diagram shows a sketch of the graphs of y equals f of x and y equals g of x. Part A asks us to find the coordinates of the points A and B. Part B asks us to find the area of the region R. Okay, for part A, to find the coordinates of the points of intersection, we're going to set the functions equal to each other. So to solve this modulus equation, we can see we're going to have two solutions. So if we first let x minus 4 be positive, this will give us point B. So where we let x minus 4 be positive, and if we expand here, we have 2x minus 8 minus 8 equals x minus 9. So we have x being equal to 7. Now if we want to find the y coordinate, we can just use either f of x or g of x. G of x is simpler here. So to find the y coordinate, we're going to do 7 take away 9, which is minus 2. So B has coordinates 7 minus 2. Now doing the same for point A, where the graph was initially negative, then we're going to have 2 times minus x minus 4 minus 8 is equal to x minus 9. And expanding the brackets again, this time we have minus 2x plus 8 minus 8 equals x minus 9. So we have 3x being equal to 9, so x is equal to 3. And again using g of x, so y equals 3 minus 9, which equals minus 6. So our coordinates for A at this point are 3 minus 6. Now for part B, we need to find the area of the region R. So first of all, it would be a good idea to find the coordinates of the vertex of the modulus graph here. And to do that, we can think of it just like a quadratic. Our x coordinate will be positive 4, and then the y coordinate minus 8. So here we have 4 minus 8 as the vertex. And probably the easiest way to find the area is to draw out the region R and enclose it in a box. Now we know the coordinates of these points here. So here that's A, 3 minus 6. This one up here is B, 7 minus 2. This here is the vertex at 4 minus 8. Now to find this area R, what we can do is we can find the area of the entire rectangle here, and then take away the areas of each of the little right angle triangles around it. Now if we think about finding some distances, for this side here, we've gone from minus 6 up to minus 2, so this height here is 4. And similarly, this length here, we've gone from minus 8 up to minus 6, so that length there is 2. This length across here, we've gone from 3 as the x-coordinates to 7, so this length here is 4. This length here, we've gone from minus 8 to minus 2, so that's 6. And this length here, we've gone from 3 to 4, so that is 1. And this length here, we've gone from 4 to 7, so that gives us 3. Okay, so if we think about the area of the entire rectangle, that will be our 4 times our 6, which is 24. And for the 3 right angle triangles, for the top left one, we're going to have 4 times 4 divided by 2. Then for the bottom left one, 2 times 1 divided by 2. And then for the final one, 3 times 6 divided by 2. So this gives us 8 plus 1 plus 9, which is 18. So the area of the region R is going to equal 24, take away that 18, so we get 6 units squared. Okay, for our next question in exercise 2G, question 2, the functions f and g are defined as f of x equals minus the modulus of x minus 3 plus 10, and g of x is 2 times the modulus of x minus 3 plus 2. And we're asked to show that the area of the shaded region is 64 over 3. Now we should be able to spot that this shape formed is a kite, and the area of a kite is equal to a half times its width times its height. So we're looking to find the height there and the width here. Now to find the height, we can use the vertex of each modulus graph. So for f of x, the vertex is going to be 3, 10, and for g of x, our vertex is going to be 3, 2. So the difference in y coordinates will give us our height, which is 8. So the height of the kite is 8. Now for the width, we need to find the points of intersection. So here we're going to set the two functions equal to one another. And if we rearrange, we get 3 times the modulus of x minus 3 equals 8. And so modulus of x minus 3 is equal to 8/3. So our two solutions are going to be where x minus 3 equals 8/3 and where x minus 3 equals minus 8/3. So our first one here, we have x equaling 17/3, and our second solution is going to be x equals 1/3. And so we have the x coordinates now. Here it's 1/3, and here it's 17/3. So we now know that the width of the kite is going to be 17/3 minus 1/3, which is 16/3. So our area is equal to 1/2 times the width times the height, which gives us 64/3 as required. Now for our final question from mixed exercise 2, part A says sketch on a single diagram the graphs of y equals a squared minus x squared and y equals the modulus of x plus a, where a is a constant and a is greater than 1. So if we draw some axes, okay, and if we draw the parabola on first, so we know that it looks something like this, where it's symmetrical about the y-axis, and we know that this y-intercept is going to be a squared, and then the two solutions are going to be a and minus a. Okay, now for the modulus graph, y equals x plus a, then we're going to have it intersecting the y-axis at a, and then the x-axis at minus a. So we're going to go through this point here as well. Okay, and then because it's a modulus graph, we have to reflect anything underneath the x-axis above it. So this part of the graph on the left, we're going to reflect upwards, like so. Okay, now we've already done part B. Part C says that given that the two graphs intersect at x equals 4, calculate the value of a. So we know that the intersection where x equals 4 must be here. And this is where the modulus graph is positive. So we're going to have a squared minus x squared being equal to positive x plus a. So if we rearrange to get 0 on one side, then we're going to have x squared plus x plus a minus a squared is equal to 0. And we know that when we have x equals 4, then we'll get a solution. So if we plug in x equals 4 here, we have 4 squared plus 4 plus a minus a squared equals 0. So we're going to have 20 plus a minus a squared equals 0. And if we multiply 3 by minus 1, we get a squared minus a minus 20 is equal to 0. And we can factorize to get a minus 5, a plus 4 equals 0. So we have a equals 5 or a equals minus 4. But remember in the question we're told that a is greater than 1. So a equals 5 is our only solution. And that is our final answer. And that is the end of the challenge question walkthrough for Edexcel's Pure Year 2 textbook, Chapter 2. I hope you enjoyed and I'll see you in the next video.